Today we are going to solve Cambridge IGCSE paper 4, which is of physics, and this is a February March 2023 variant 0625 and 42. Let's start off with the first question, and the first question states that boat crosses a river. The boat points at the right angle to the river bank, and it travels at a speed of 3.5 meters per second relative to the water. The river currents act at the right angle to the direction of the boat points. The river current has a speed of 2.5 meter per second. By drawing a scale diagram by calculation, determine the speed and direction of the boat by relative to the river bank. Again, now you see that the river is moving in this direction. So, what we can do is this 1 centimeter equals to 1 meter per second. So for this, let's suppose if you want to draw the current for 2.5, so it's going to be 2.5 centimeter. Then you have to draw this. This is going to be 3.5 centimeter. This is going to be this one, and this is going to be this one. Now you see they are both at right angle triangle, so you can use the vector addition of forces by parallelogram method or tip to toe or head to tail rule. Okay, so again, now you see this thing, this is right angle triangle, so I'm going to apply the Pythagoras theorem, so which is hypotenuse square equals to perpendicular square plus base square, and this is going to be 3.5 square plus 2.5 square and square root, and this is going to give you the answer is going to be approximately 4.3 meter per second. So your speed will be 4.3 meter per second, and the resultant force can be like this, or it can be like this, and then this is going to be your resultant force, and over here this is your resulting force. Again, now you can apply tan theta is perpendicular over this. Okay, so you can do this 3.5 over 2.5, so you can do this tan inverse 3.5 divided by 2.5, which is approximately equals to 54 degrees. So the direction would be 54 degrees. Okay, speed is a scalar quantity and velocity is a vector quantity. State what the names of one other scalar quantity and what other vector quantity. So you can write distance and displacement. Okay, so this is like this, and this can be mass, and this can be weight as well. Okay, moving to the next question, and it says that figure 2.1 shows a ship loaded with the containers, and the ship is made up of steel. The density of the steel is this, and the density of water is this. Explain why the ship floats in the water. Okay, why the ship floats in the water? Because ship is not ship has air pockets, air spaces, is not solid steel. I mean, it's made of, there are rooms and there are spaces, so it's not going to sink. And you can also write this thing that the overall density of ship is less than density of water, so that's why it's floating. Okay, the container with greatest mass are loaded near the bottom of the ship. State and explain the effect on the stability of the ship of loading the container in this way. Okay, so basically this is center of gravity. So if you increase the mass, at the bottom. So obviously there will be the center of gravity will be more, obviously the object will be more stable. Increase the mass at bottom, the more stability. Okay. Okay, now moving to the next question. A crane lifts a container 48 meters vertically upward. The mass of the container is this. Calculate the energy transferred to the gravitational potential energy stored in the container. So again, gravitational potential energy is equals to mgh. M is 3123 times 9.8. Height is 48 meters. So if you multiply this, you will end up with 1.41 into 10 to the power 7 joules of energy. Okay, now moving to the next question, which states that state the principle of conservation of energy. So we know that energy cannot be created nor destroyed, but it changes its form. Okay, a wind turbine has a maximum output of 1.8 10 to the power 6 watt. The turbine operates at maximum power for 4 hours. Define the unit of kilowatt hour. So 1 kilowatt of power in 1 hour. So this is the simplest definition for this. Calculate the energy produced by the wind turbines operating at maximum power for 4 hours. Give your answer in kilowatts hour. Okay, so we have already done this. 1.8 into 10 to the power 6 watt is going to be converted into 1.8 into 10 to the power 3 kilowatts. So energy is equals to P times T. P is what? 1.8 into 10 to the power 3 times 4. So it's going to be 7200, and the energy would be 72 kilowatts hour. So 72. Okay, we got the unit. Okay, the radiation from the sun is the main source of energy for most of our energy resources. State two energy resources that are not due to the radiation of sun. So this is one as geothermal. Then we can talk about nuclear, and we can also talk about tidal. Okay, so moving to the next question. Figure shows metal pan on an electric hot plate. The pan contains 200 centimeter cube of water. The pan is heated. The temperature of the water in the pan increases. Thermal energy is transferred through the metal pan of by conduction state, and explain two ways that thermal energy is conducted in a metal. So obviously there are free electrons in the metals, and you can also call them delocalized electrons. Okay, electrons, they collide to transfer energy. They also do the vibration thing. So obviously when they do vibrate, so they are going to uh, transfer their energy. So I'm writing in a simplest way. You guys can write it in full sentences in a paragraph format. Okay, the water boils and leaves the liquid as gas. Explain in terms of forces and distance between the particles why the gas occupies a much greater volume than it does as liquid. So bond forces between liquids is greater than gases. So the intermolecular forces of the gases are weak. Okay, now if you do this in gas, particles are further apart the liquid. There are two ways in which boiling differs from evaporation. So, in boiling, it has or it occurs at fixed temperature, temperature, and the boiling it happens throughout the liquid. Okay, moving to the next question, and the water is replaced with 200 centimeter cube of milk. The initial temperature, this is the volume. The initial temperature of the milk is 20 degrees Celsius. The boiling is this one. The milk starts to boil at this much of energy. The density is this. Calculate the value of specific heat capacity. Give your answer in three significant figures. Okay, so first of all, what we are going to do is we are going to find the density is going to mass over volume. Mass is what? Okay, we are going to we need to find out the mass. So density times volume is going to be mass. So putting the values inside it is going to be density of the milk is 1.03 times volume is what? 200 centimeter cube. So this is going to be mass is going to be 206 into 10 to the power minus 3, and this is going to be the mass. And now we are going to put it in the specific heat capacity formula. Q is equals to mc delta T. Q is 60700 joules of energy, then divided by 0.206 into 95 minus 20. So this will give you around 3930. uh, this is going to be joules per kg. MC, okay, sorry, this is going to be m delta d. Okay, so this is per kil. Okay, so this, if you round it off to three significant figures, yes, this is three significant figures. Okay, figure shows a semicircular transparent plastic block. A semicircular transparent plastic block. A ray of light is incident normal onto the curved surface of the block. The refractive index is this. Calculate the critical angle. So n, okay, sine c equals to 1 over n. So c equals to sine inverse 1 over 1.5. This is going to be 41.8 degrees. So this is going to be 41.8 degrees. On the figure 5.1, draw the path of the ray block after the ray emerging from the block. Okay, so what we can do is draw the straight line with the help of scale and draw the normal. This is angle of incident. This is angle of reflection, and we can also do this thing that it can be reflected as well. Angle of is, if it is refracted, then it's going to be this, and if it is reflected, then it's going to be this one. Reflected, this is the one, and for refracted, this is the one. Okay, for 5.2, the scale shows a scale diagram of an object. So you have to remember this thing. Whenever the object is placed inside the focal length, the image will be formed at the back. So this is going to be, again, you have to use the scales to draw these diagrams, because it's going to be the optical center. So this is going to be your image. Okay, the point marked F shows the position of the principal focus, determine the focal length. So you have to determine the focal length. So you have to measure this thing and find out the focal length at this point, which is going to be 6.9 centimeter. On the figure 5.2, draw two rays of the object. This we have already done. And then we have this question. which states that simplified diagram of the human eye with the ray from a distant object, and the path inside this is like this. So basically image is formed before retina. So this is image is formed before retina, so it should be formed on the retina. So draw a digital okay, so you need a divergent lens to do this thing. So rays of light will come like this. One, okay, draw the straight line, okay. Two, oopsie. So this is going to be the right image. Okay. Sound waves have compression and fractions. Explain what is meant by compression. So particles are close together. Particles are close together in this scenario. Okay. And over here the particles are further apart. So that is basically there. We can see the light from the sun, but we cannot hear any sound from it. State the reason for this. So light does not need medium to travel, whereas sound does need a medium. During a thunderstorm, an observer sees the lightning almost immediately, but hears the sound of the thunder several seconds later. The thunder and the lightning are produced at the same time. The sound of the thunder is heard 9 seconds after the lightning. The speed of sound in air is this. Calculate the distance from the thunderstorm to the observer. So V is equals to distance divided by time speed. So simple as this, V times T. So V is what, 340 times 9, which is going to be 3060 meters. So for two significant figures, we can write it down 3100 meters. Okay, moving to the next question, and it states that in a lightning strike, there is a current of this much for 48 milliseconds. Calculate the charge that flow. Now you see the thing that I is equals to Q over T, but we need to find out Q, which is going to be I times T. So I is what, 3 into 10 to the power 4 times 48 into 10 to the power minus 3. So when you multiply this, you will end up with 1440 coulombs, or you can write it down 1400 coulombs in this place. Okay, define potential difference. Potential difference is amount of work done in moving a unit positive charge from infinity to that point is called as potential difference. Electromotive force has the same formula, W over Q. The EMF of a battery is 9 volts. The battery is in the circuit. Calculate the work done when it moves the charge 30 coulombs. So 9 times 30, 30 is 270 joules. So this is the formula, EMF equals to W over Q. So put in the values and you will get your answer. This is going to be 270 joules. Circuit consists of a DC power supply, a lamp, and a thermistor. A DC circuit comes a power supply, a lamp, and a thermistor. So for a thermistor, it's going to be like this. Draw the circuit of these components in series. So we are done with this as well. Explain what happens in the circuit you have drawn in C1 when the temperature of the thermistor is increased. So when the temperature is increased, When the temperature is going to increase, the resistance will decrease, and when this is going to decrease, so obviously resistance of the circuit is also going to decrease. There will be more current inside this. There will be a bright lamp, the or you can say the brightness of the lamp will increase. There will increase in potential difference as well. So these are the things, you can write any of the two to justify your answer. Okay, shows horizontal flat coil in a magnetic field. The coil is connected to a cell. The coil rotates. Determine the direction of the movement of AB relative to the plane of the coil. Direction of the movement is going to be downwards by using Fleming left hand rule, and it's going, or you can say it's going to be anti-clockwise. Explain how you determine the direction as this. Again, you can write it down, Fleming's left hand rule. State and explain what happens to the coil as it reaches the vertical position. So it's going to be, the coil is going to stop. The turning effect is going to decrease or is equals to 0, or you can say it's going to decrease. Turning effect is going to reverse, or you can say change just the direction. Okay, to operate as a motor, a splattering commutator and brushes are added to the part of shown. Explain the effect of splatterings, commutator and the brushes on the action of motor. Okay, first thing is this, like brushes is okay. First thing is, to operate a motor, commutator are added as a part as shown in figure 8.1. Okay, it reverses the current. Brushes ensures current is maintained, coil rotates continuously in same direction without tangling, or you can say wire don't tangle. Okay, now moving to the next question, and it states that nuclear power station has a reactor where controlled nuclear fusion of uranium 235 takes place. Explain what is meant by nuclear fusion. So basically, in this, the radioactive element splits up into two daughter radioactive nuclei, and then it's going to be neutrons plus huge amount of energy. So this is basically the equation of nuclear fusion. Okay, so state one advantages and disadvantages of generating electric power in nuclear power station compared to this. So obviously, advantage is this, like it's a continuous supply of energy. Basically, you have a huge amount of energy by this process, and continuous means that you have got huge amount of. Okay, and disadvantages is this renewable energy source. Okay, deuterium is an isotope of hydrogen with one proton and one neutron. So deuterium is one. This nuclear fusion occurs when two nuclei of deuterium combines and isotopes of helium is going to form and use the nuclear notation to write down this 1 and 0. So this is the equation that you are looking for. The time taken for Mars to orbit the Sun is 690 days. The average orbital radius of the Mars is this. Earth day is 24. Calculate the average orbital speed. So this is 2 pi r over t. So 2 times pi radius is what? 2.28 into 10 to the power 8 kilometers divided by t. Time is 690 times 24 times 60 times 60 is going to be 24 kilometers per second. So this is going to be your answer. State the shape of orbits of the planets. It's ellipse or elliptical. Elliptical. Light from the distant galaxy is redshifted. Explain what is meant by redshifted. So, wavelength is going to increase, or it occurs when galaxies are moving away from occurs when galaxies are moving away from Earth. Say to the quantity that the redshift of galaxy is used to calculate is it's used to calculate speed or velocity. So I hope you got these questions. If you have any queries or any questions, write me down in the comment box. And thank you very much.